Any question from last time? So, actually there should, because I may have made a blunder here, which oh, that guy did not come, is here. You know, if the outcome of the system is a ranking, is it clear what does strategy proof mean? For voting rules, the outcome is a one candidate. So, it makes sense, it is easy for me as a voter to compare two outcomes, which one I like. But if the output is two rankings and I have another ranking, so for some candidate that is better, for some candidate other is better. So, for strategy proofness, for social welfare functions, this strategy proofness does not make much sense, or it is not clear. Yeah, you can define many ways, but it is not very clear that, and that is why even in Arrow's theorem we do not have strategy proofness, we have another condition and that condition is there. So, this is not. The third condition is actually non-dictatorship. So, this is the correct Arrow's theorem, that whenever we have at least 3 alternatives, there is no social welfare function which is Pareto efficient, IIA and non-dictatorship, not strategy proof. Good. Okay. Now, as proposed, so let us see a popular domain restriction which will bypass this Gibbard-Satterberg theorem. And that domain restriction is called a single peak domain. So, what is single peak domain? Single peak domain says that there is one prime issue in that election. So, think of an election, in US elections or even in Europe elections, there are all the candidates are aligned in some sense on a axis where you have either Democrat, another is Republic. Okay. So, these are two extremes and various other candidates are in between. Yeah, you had some question? No, okay, fine. So, this is modeled based on that motivation. So, what is the underlying assumption? That there exists a permutation or ranking, let us say, sigma, say sigma m. M is the number of candidates so let us call it, say, that means A sigma 1, then A sigma 2, here is A sigma I, A sigma m. Such that whatever the underlying principle gives me this ranking. As I said, in political, especially in political elections, these kind of phenomena or behavior is observed between two extremes of political spectrum. Each voters are also divided. Each voter also has some best candidate. Say a voter, any voter has he or she feels that this guy is the right mix of both extremes. So, typically extremes no one like because they are clearly not the best. So, but voters may think, okay, maybe this is the right mix, this is the right mix, this is the right mix, and so on. So, for example, this kind of axis you can also imagine for say capitalism versus communism, various other ways. So, extreme of communism maybe I do not know China, US, China, Russia, extreme of communism US, where one of my PhD student Arnab Maiti, he is in University of Washington, he is doing PhD there, and he was telling me it is cost effective for him. So, he has to remove his wisdom teeth, it is paining. So, it is cost effective for him to come to India, remove his wisdom teeth and go back than the medical expense there. So, it shows the extreme of capitalism. So, I think Europe you can see in my opinion right mix. So, many basic things are communism principle, education, and education is kind of free in many European countries. Yeah. So, everyone has opinion. So, the point is there are often this kind of societal axis exist, and various candidates are positioned in this order, and every voter has feels that this guy is the right mix. Now, what is the restriction on ranking then this imposes? The restriction on ranking is that if that voter top guy is this, that means for a voter VI, the most suitable candidate, if it is A sigma I, most preferred candidate, then for any rational voter he should prefer this guy, this white guy over this blue guy, right, because it simply I do not need to know the distance in say kilometer or meter terms, but this white guy is closer to this most preferred guy than this blue guy. Makes sense? So, if I fix the top guy, I am saying that on this set the ranking should be this way, and for this part the ranking should be this way. It is not defined. So, it is part of the definition of single peak domain.
No, what is A sigma? Is it a set? Is it a one person? What is?
Sigma is a permutation of M, and M is the number of candidates. So, this is a particular candidate.
No, I am confused. What is sigma I and what is A sigma? I mean,
sigma is some number, because sigma is a permutation of 1 to M. So, sigma 1 may be 10. So, then A sigma 1 is A10. So, assume that the candidates, that candidate set A is, yeah, I should have written this A1 to AM. So, for the sigma permutation of M, so this is a ranking on, this is an L A, this is a ranking of candidates. Okay. And given a ranking of candidate, I am defining which rankings, which preferences are single peaked with respect to this ranking. This I am defining, definition.
sigma is not just one number, it's a full permutation.
Sigma is a permutation. Oh, why I am written? This is Sm. This is a set of all permutations. Yeah, sorry. Yeah, again blunder. This is a set of all permutations of M. So sigma is a permutation. See, now, yeah, this should be fine. Sigma is a permutation of 1 to M, and now this is a ranking or permutation of the candidates.
So sigma I is ith position.
Correct. Yeah.
So A sigma I is what?
A sigma is the ith most preferred candidate in this preference ranking. But this does not correspond to any voters ranking. So I am defining what is single picked. Yeah. So this is part of definition. So if top guy is A sigma I, top candidate, then single picked restriction says that the left guys can be ranked only this way. That means the farther you go from top guy, you should prefer candidates less. Also on the right hand side, but they can mix arbitrarily. What do I mean by that? Let's see a concrete example. Maybe the single picked order is, I don't know, A5, A1, A3, A4, A2. Right? Now, what are the voters' preference could be? Suppose the voters' preference is A3. Top guy is A3. Then, if top guy is A3, then the voter must prefer A1 over A5, voter must prefer A4 over A2, but he has complete freedom to choose between A1 and order of A1, A4. For example, this is valid. So this is single picked with respect to this. This is also single picked with respect to this and various others.
So before the election,
yeah,
someone gives this order as well as the winner.
No, there is no winner yet.
A top guy, whatever that.
It's like a social access.
Yeah. So suppose that the election is such that there exists a order of the candidates, alternatives, where votes are like this. So it's not like someone is asking voter, your vote must be this. It's just the type of election, say US election or typical political elections. Often now things are getting polarized more. We have one or two issues and people candidates take position. So in those sort of things, this ranking of the candidate is along that spectrum, like say communism versus socialism, communism versus capitalism. This kind of spectrum. So that defines this, and preference is called single picked if you restrict this preference on this set, you get this ranking. If you restrict this preference on this set, you get this ranking. These two guys can mix arbitrarily.
The peak can be different for different
people, right? So for example, for a single even if you fix this societal order, this is called societal order. Right. Even with this societal order, how many different rankings can a voter have? So top could be M, one of M. But for every top, there are many things, right? So if you do the math, it turns out it's not very difficult, but may not be very easy also. That given any societal axis, there are 2 to the power m or m minus 1. So let me write big O of 2 to the power m. This many rankings which are single picked with respect to any given thing. Yeah.
If the top is last, then it is fixed. It must be.
If the top is one extreme, it is fixed.
Okay.
but majority of the top is in between, no? Yeah. So yeah, so this, so it's not, it's rich enough. That's what I mean. In full generality, each voter can have say m factorial rankings, which is like m to the power m or 2 to the power m log m, whereas this like 2 to the power m. Okay, now so such that this if Vi's preference is this such that if let me write Pi is the preference of Vi. If Ai is at top, then the condition is Pi restricted to this set A sigma 1 to A sigma I minus 1. If you project this ranking on this set left part, it should be A sigma I minus 1 to A1 and Pi restricted to A sigma I plus 1 to A sigma n m should be A sigma I plus 1 to A sigma m. Right, that's exactly the condition. But you know, you have full freedom to choose the order, say between A sigma I minus 1 and A sigma I plus 1. These are the things. And when do we say a set of rankings is single picked? If there exists one ranking of candidates with respect to which every preference is single picked. So, what is a, let me write, single pick profile? A profile or a set of rankings is called single picked is called single picked if there exists a sigma in Sm such that every ranking is single picked with respect to sigma. There exists one order, societal order with respect to which all the rankings are single picked.
So can you give a small non-example? Some two profiles, a small profile, I mean.
Which are not single picked?
Yes.
But that will be difficult to prove. But you know, if you take say I think 3 candidates and take all possible rankings, I think there will be 6 rankings. That will not be single picked.
Sorry, could
You take 3 candidates,
yes.
3 alternatives,
Yes.
and how many rankings possible? 3 factorial,
Yes.
6. Take that profile. That is not single picked because there does not exist any ranking of the alternatives with respect to which all 6 are single picked.
That needs proof.
Next proof.
Okay.
Yeah.
What do you mean by every ranking in single pick with respect to sigma? Sigma already induces a ranking, right?
Sigma is this.
How that induces a ranking?
This is a ranking, but there is not any voters preference. Voters preferences are this P1, P2 and this sort of thing. So there are two kind of things. A set of rankings, let me write this way. Think of this as voters preferences P1 to Pn. These are the preferences of the voters, which are also ranking. Is single picked if there exists a sigma, which is this societal ranking. So that every ranking Pi is single picked with respect to sigma.
It's like a profile.
Correct, profile, yeah.
So I understand this projection thing what you are doing. Suppose I give you one voter's profile, like how you are, and I give you the sigma, universal sigma also. How do we verify that this is single peak with respect to this sigma? Like,
Yeah, can someone answer? So the question is, I give you a voters ranking
just one
and
vote.
give you sigma, one voter ranking and sigma. How can I test whether this PI is single peak with respect to sigma?
This will violate.
Look at the first person. So that gives me partition. Look at the top most candidate.
Yes.
Find it there. That gives me partition of these two parts.
Okay.
Now restrict this PI on each of the parts and see whether the ranking induced are this or not, because that is the condition.
Oh, okay. So testing given the like set of all PIs are single
And
peak
sigma is easy.
easy. Okay.
Now here is a natural computational task, is that if I don't give you sigma and ask does there exist a sigma with respect to which all P1 to Pn are single peaked or not. So not obvious, you can't go over all sigma, but there is a polynomial time algorithm for it. Okay, now let's see how I can get very beautiful voting rule which satisfies all these things and many more. Yeah.
What do you write over the A sigma I minus 1?
Here
Up to
up to A1. It says that if I restrict my PI on this set, then who is closest to top guy in this set? A sigma I minus 1. So this guy should be the most preferred among these candidates, followed by next guy, and this guy should be least preferred. Same on the right hand side. On this set of candidates, A sigma I plus 1 is closest to top guy. So this should be the top guy in this set, and A sigma M should be the last guy.
Shouldn't that be A sigma 1 instead of A1? Same inequality. Sure.
Yeah, sigma 1. Yeah.
Sir,
Yeah.
sir, what is the application of finding that universal?
The application is, so often we have election data, and I will give you an amazing voting rule which has all the desirable properties in the world you can think of. Now, but the question is, to use that voting rule, you need to make sure that it is single peaked. Your set of ranking is single peaked. So you have historical data. You test whether these political election preferences are they single peaked or not. If it is single peaked, then you can use it. Otherwise, it is of no use.
Like societal order in real cases, what?
That may not be make sense. May not be sometimes obvious. So forget societal order. If there exists a sigma, if a set of ranking satisfies this thing, this property for some sigma, that sigma I will call it societal order.
Find polynomial.
Yeah, not obvious, but there exists a polynomial time algorithm. Huh? If one exists, correct, or detect that it does not exist. So it's polynomial. This problem computational task is in P.
There can be multiple.
Yes, of course. For example, if no, you find example. But yeah, I'm just keeping something. You can ask. We will discuss all these things in tutorial. Find a profile where there are multiple sigmas with respect to which these are single peaked, more than one sigma. Okay, easy. These are very easy examples. Easy but fun. Yeah. Okay, so now let me introduce the amazing voting rule that is called median voting rule. So recall what is the voting rule. It will take the rankings as input and output one winner, right? That is a voting rule. So what it does is it only looks at the top guy, like plurality. Like plurality, it only looks at who is the most preferred and ignores the rest of the preference. And it draws a histogram. how many voters have A sigma 1 as top guy? How many voters have A sigma 2 and top guy? And so on. We have this histogram. Okay, is this histogram clear? I have just plotted a bar chart how many people have A sigma I as a top alternative. And as the name suggests, you find the median of this histogram and that declare that guy as the winner.
Are there in a descending order?
No ascending descending. This order is determined by sigma. So this can go high, low, high, nothing. All kind of thing can happen. But this order, because there is a order sigma, this median makes sense. What is the median? So median is a guy A sigma which may have small height, but including this total sum of these buildings is greater than equal to n by 2 and sum of these buildings is greater than equal to n by 2. So if n is odd, so let us make n is odd and we will worry about even in tutorial. So n is odd, if n is odd then median is unique. Okay, so it is uniquely defined, so winner is median. Winner is the median, there is a unique median. Okay, yeah, question?
So median need not even have a single vote. Nobody might have voted him as first person. But still get.
If n is odd, can that happen? Sorry?
No, that doesn't contradict unanimity.
Sorry, just one by one maybe. Yeah. So if n is odd,
Still that person must have voted for someone.
yeah, for n is odd, it may not be true. Yeah, for n even this can weird thing can happen. That's why I have conveniently assumed n is odd. But yeah, so yeah, yeah.
So the height is the number of people who have
Vote.
that particular
Correct.
alternative as the top.
Exactly, exactly.
So big.
Because unanimity.
Unanimity says that it is, if there is one candidate whom everyone prefers, then that guy should be the winner. So let's apply that profile. So if there is a candidate whom everyone prefers, then how does the histogram look like? One guy has whole pillar, and that is the median.
Also the zeros.
See, that does not satisfy the definition of median. This is included. So what is the median of this? So suppose this, if I have A sigma 1, A sigma I, suppose A sigma I has all votes. So he is talking about that unanimous ranking. So he told that there is a candidate whom everyone prefers. So if I draw the histogram, this will look like. What is the median? Only this. Because the condition is from here to here should be n by 2 greater than n by 2 and from here to here.
But you are not sorting based on.
I am not doing anything, the order is already given. Order is the sigma.
Okay.
There is no sorting going on, that's why I deliberately, do you want, I can draw again big, small, beside big buildings you can see slabs. So this kind of picture.
So
It can still be zero, right?
Sorry?
The median can have 0 votes.
I don't see an example, I would be happy to see an example for n equal to odd.
basically, what I'm saying is, suppose there are some 10, whatever number of candidates, and say some 20,000 votes, and lot of people prefer. I mean, we are trying to infer this order.
No, this order is given. For median voting rule. Median voting rule only makes sense. It is defined only for single picked domain, single picked set rankings. If your input is not single picked, it is not defined.
Is it because the extremes are always?
It is
the
not
worst?
defined. How will you define? You
No,
need
no.
sigma in that definition. Sigma is not any arbitrary sigma. This is the societal order sigma.
I'm saying in the societal order we know the extremes are worse, so maybe.
No, there is nothing like we know. Hitler also can become hero, no? He became hero, no? So it's nothing like, so people perception can change, nothing like that.
Basically, like for a lot of people, peak is on the left side, and for a lot, like the other half, the peak is on the right side. Then the median will neglect both the peak and pick someone in
Yeah.
the middle.
That
But-
does not violate any our desirable property. So yeah, it can happen that 49% people like this guy, 49% people like this guy, and 2 people or 2% like this guy, and this guy is the winner. We will see what are the nice properties this satisfy.
The median is independent of the votes.
Median is independent of
Votes, of the votes.
boards.
Votes. He's saying you will
Votes.
always choose median, right?
No. This histogram is drawn from the votes, no?
Yes, but does the median depend on the
Histogram, of course. What is okay? So if the term median is confusing, find I. So start from here. Start from her. Is it greater than n by 2? If it is less than n by 2, take this. Is these two greater than n by 2? Less. Keep going. Stop the first time when you exceed n by 2. That guy is the winner. Okay. So you start the smallest I such that the sum of these buildings till sigma I exceeds n by 2. That is my median.
Oh, okay. So basically, if a lot of people are capitalist and a lot of people are communist,
Then I will win in the middle. Yes, correct. Yeah.
but everybody would be unhappy though.
That depends. So now let's prove. Okay. But it seems you are very unhappy with this voting rule. So let me prove that this is a very good voting rule. First of all, let's prove it is strategy proof. But before that, is the voting rule is clear? If I give you a set of single picked rankings with sigma, can we compute the winner? Is simply write down list the candidates according to sigma and keep counting the cumulative votes like cumulative distribution, and the first time you exceed n by 2, that is the winner. Okay. Now strategy proofness is very easy. Nobody can benefit by lying. So let me do the half proof and then you finish the proof. The first step of the proof is if the voter top guy is already the winner, then he has no benefit to lie. The other case is if it is not. So here also you can make your life simple by assuming that they are only voting for one candidate, forget ranking. Because only top guy is being seen by the algorithm, considered by the algorithm, rest of the preference is ignored, right? So you can as well see that like Indian elections, every voter go and vote for one candidate. But then does he have incentive to say wrong vote? Anyone? Yeah. Yeah, but you know, and there is no probability. You are rephrasing this thing.
If he is aware of the social order,
Everyone knows social order.
then so if he is aware of the social order, and then he can arguably shift towards the one side so that the median is closer to the
Yes, but then that will not that will show that it is not strategy proof.
Yeah.
It makes sense.
So, but if he supposedly somebody's most preferred is A sigma 2, but the winner is A sigma I. If he misreports as something to the opposite of A sigma I, then it
Yeah, stop. You know, in any news channel debate, whenever some guy start to make sense, the news anchor stops him. So I have to stop her. Yeah, you are right. Actually, she gave the proof. You know, I gave the 50% of the proof that, you know, think of a voter V. If his top guy is this guy is top guy is the winner. No point of lying. He's already his best guy is winning. If his best guy lie in this region, left part of the winner, then let's see what happens. What can happen if he misreports, votes for somebody else. If he votes for any guy from A sigma 1 to A sigma I, then does the result change? No. And if he votes for any guy from A sigma I plus 1 to A sigma M, then if the result change, the median is only going to shift away from A sigma I. Let me repeat. If he votes for some guy in this region, and if that changes the result, then the new winner can only come from this part, which is now, if his peak is this, whom between this and somebody here, whom he likes more? This guy, because this guy is closer to his peak than any guy here.
Could you please repeat?
Yeah.
So you assume it's SP, right? Single peak.
Yes, everything is single pit. Otherwise, you know, this definition does not make sense. The argument is, let me repeat. Suppose A sigma I is the winner. Think of any voter. If his top guy is A sigma I, nothing to his top guy is already winning. Let's assume its top guy is not A sigma I, it is somebody here on the left side of A sigma I. Now let's analyze. Okay, so if he misreports his top candidate, what that could be? That could be either in this set A sigma 1 to A sigma I. If he reports the top guy in this set A sigma 1 to A sigma I, then median does not change. A sigma I remains median. Take it as a homework. On the other hand, if he reports top guy to be somebody in this set right of A sigma I, then median may shift, may change or may not change. But if it changes, it will only change to somebody here, which is worse for this candidate because his true peak is here on the left of A sigma I. His happiness, he can misreport, but his happiness depends on his true preference. Right?
So currently sigma 2 is his choice, right?
Suppose So suppose sigma 2 is his best candidate.
Yes.
Right? So between sigma I and say maybe sigma I plus 1, whom does he prefer more?
No, sigma I. That's
Sigma I.
So voting something to the left of this blue line.
Winner is sigma I.
No, this blue line.
This blue line.
If I misreport something in between.
Sigma 1.
Yeah. So why is it not shifting the median closer to this?
Median is this.
because the sum is-
Cumulative sum remains same.
Oh, right.
Okay.
Right.
But yeah, it can sometimes be confusing. Yeah. Recall who is the winner? I start counting. The first I where A sigma I, this cumulative is exceeds n by 2. That is the winner. So strategy proof. Is plurality strategy proof? Obviously no from GS theorem, But can you give me intuitive reason why it is not strategy proof, or give me an example? Yeah. Correct, sort of this thing, but for a more kind of intuitive level, say on a political election, there are two main parties in my constituency, right? Say party A and party B, and there are some chutka chatka, they don't have any chance of winning. My friend also submit nomination, he is also one candidate. Now my friend may be my top choice, but for me it does not make any logical sense to waste my vote giving my friend, other than, so I know that these are the two parties so who have any chance and they have the competition, so I will then give vote the better of the two, no, which I think we always we do typically, and that is from this framework, this is not strategy proof. You are not reporting in true top guide. So if it is single picked and if median voting rule is used, you don't have to think about this thing. You can just go and vote for your friend, and this voting rule will take care of and select the winner.
But in the plurality case that you gave, you are not better off, right? Your best choice was the other candidate.
No, I have a ranking actually. You see, although I am voting for one candidate, I actually have a preference ranking. So I am better off with respect to that ranking. So that is the first good thing. Second is, yeah.
What if I try to change my ranking before that single pink domain has been chosen?
It's not like whether you try to change or not. It's like historical data says that people in this sort of election, say US election, so people opinion are polarized along this line. Yes. So if indeed there in some elections this sort of structure exists, we can have beautiful voting rules. As Gilbert-Satterberg theorem says that for arbitrary domain there is no good voting rule. As I said, in plurality, although these perfectly make sense and very common. So that's why many people from audience, once I tell this, they ask, you should change the definition of strategy proof, manipulation, because this makes sense, right? So that's why. So okay, so that is the first property. Second property is Condorcet consistency. So Condorcet consistency. Can someone prove that the median is the unique? Whenever a Condorcet winner exists, then median is that Condorcet winner. So let me recall what is a Condorcet winner. Condorcet winner is the candidate who defeats every other candidate in head-to-head election. Right? That is, he is called Condorcet winner. It may exist, may not exist. Condorcet consistency is, if a Condorcet winner exists, the voting rule should pick that guy as the winner. Is the median not always Condorcet winner? I claim median is always Condorcet winner. Right, every profile, assume n is odd, make life simple. Median is always Condorcet winner. Median defeats every other candidate head to head. right?
Yes.
Yeah, anyone say why? Why median beats everyone, every other candidate head to head?
Like, can we think in this term that uh, before that median it was less than n by 2. So for a sigma 1 less than n by 2 people will vote, and for a sigma I more than n by 2.
Yeah, sort of that thing. So if this guy is a median, then this sum is greater than n by 2. Then all these voters whose top guy is in this set would prefer this guy over anybody here. Let me repeat. The sum of these buildings till a sigma I is greater than n by 2. Now, do you see that if anybody has top guy here on the left part here, then that guy would prefer a sigma I over anyone here? Simple from definition. Now, there are more than n by 2 people with top guy in this part, including a sigma I. That is how I choose a sigma I. So, that means at least more than n by 2 people prefer a sigma I over any guy here. But this is also more than n by 2. So, same. So, if there is any peak here, then this sum is also greater than n by 2. That is why n is odd, n by 2 is a fraction. So, both way it is greater than n by 2. Okay? So, this is Condorcet consistent. Actually, this proved something more. It showed that if your rankings, preferences satisfy is single peaked, then there always exists a Condorcet winner. There always exists a Condorcet winner, and median voting rule picks that Condorcet winner.
Can you repeat? If this is
It shows that if your preferences, set of preferences is single peaked, then there always exists a Condorcet winner, and median is that Condorcet winner. Okay. Any question before I erase everything and change topic?
So
Yeah.
doesn't this violate the GS theorem? It is
No, GS theorem assumes that the ranking R or is from LA to the power m to a. So this is not defined. This is defined only for some subset of this. So that is the called domain restriction. I am restricting the domain of this voting tool. Yeah. So this is one classical approach. Another approach. Yeah.
What about other properties like non-dictator and
Not definitely non-dictatorship.
strategy proofness?
Yeah, this is strategy proofness. And not only that, many other properties if you can think of. From here, you can use this to get a social welfare function also. There is a natural framework to design a social welfare function from a given voting rule. The framework is you apply the voting rule, you get a winner, and you delete that winner from the input. The winner is the top guy. Again apply the voting rule and find a winner, that is the second guy, delete, and so on. So from a voting rule you can design a social welfare function. The other direction is also obvious. If you have a social welfare function which gives ranking, then pick the top guy as winner. So from this median voting rule you can define what is called median social welfare function. Basically applying median rule like this way, which outputs a ranking. Prove that that social welfare function satisfies IIA also, independence of irrelevant alternatives. The Arrow's theorem, condition for Arrow's theorem, and many things. Whatever good thing you can think, it satisfies.
So what is the problem with it?
Domain restriction. It is not for any domain.
But it is still rich enough.
Rich enough, correct. Now you have bought this thing, you will feel rich enough. Now you like this thing. Yes, so it's basically if you for elections specifically for political elections, these are very common, but it's not used. That's the way life is. It's not used in political elections because I don't know, these are old systems, and
Can be used only if given a preference list sigma exists, which may not happen in most cases. Even if it's polarized, there might be one voter's preference which might throw everything off.
correct. This sort of thing, there are some issues, but those are not main issues. Means theoretically speaking, it may be fine if you ignore, say, 0.1% some outliers. Theoretically, it may be fine, not practically. How dare you? What do you mean? No, are all people not equal? What do you mean discarding vote? Huh? What are you doing? Okay, so there are various things. So this new emerging area of explainable AI. So you can't whenever you use AI, you use machine learning models, say for medical diagnosis or say for various decision making, and then decision making can sometimes go wrong. No, because then you have to explain to whom, to common people, to judges, why this. You can't say that this neural network, these maths. No, not this. So explaining means you have to explain to common people. Oh, yeah. Okay. So in the remaining time, let me introduce you some of the interesting research questions that has been going on in computational social choice. The first one is what is called winner determination. So determining the winner of an election is one of the fundamental things. You have to at least need to compute the winner. Then strategy proofness, those things come later. So it turns out that there are various some very beautiful voting rules for which determining winner is hard. So let's the voting rule is called Kemeny ranking. Which satisfies many good properties except of course strategy proofness because Gilbert-Satterberg theorem. So and very natural, you will see. So you have these input rankings, preferences P1 to Pn. Now what you say Kemeny score. Of a ranking R. So R is also a ranking. Okay. So for every ranking, I will assign what is called a Kemeny score. So what is Kemeny score of a ranking R? It is let's look at R and let's look at P1 first. You count the number of pairs of candidates whom are ordered differently in P1 and R. Number of pairs, how many pairs are there? M choose 2. So among M choose 2 pairs, you count how many pairs of candidates are ranked differently in R and P1. That let's call the disagreement between P1 and R. Right? Similarly, you compute the disagreement between R and P2, R and P3 up to R and Pn and add. That is in some sense total disagreement of R with this input. That disagreement, the fancy term is Kendall tau distance or KT distance, but it's this. There are number of pairs of alternatives who are ordered differently in R and Pi. Okay, that number is called Kendall tau distance between R and Pi. You sum them up. So for every ranking you get the what is called Kemeny score of the ranking. So small Kemeny score is better or large Kemeny score is better? Small. So who is the Kemeny winner? The ranking with the smallest Kemeny score. So winner is ranking with the smallest Kemeny score. Prove that this is Condorcet consistent. If there is a Condorcet winner, then the way I have defined is let me not write winner, output. The way I have defined these outputs are ranking, a social welfare function. Now then what is the voting rule? The top guy. Okay, so prove that if there is a Condorcet winner in your input set of rankings, then the corresponding Kemeny voting rule will output that guy only, nobody else.
It will output that guy as the top guy, and it will output a list, right?
Correct. So that's what I am saying. If you want to go back and forth from social welfare function to voting rule, that's the thing. From welfare function to voting rule, look at only top guy. Okay, here is actually more. The output, there may not be unique ranking which achieves minimum score, right? So if there are multiple rankings, it outputs many rankings. So you prove that if there is a Condorcet winner in all Kemeny rankings, all rankings which achieve lowest Kemeny score have Condorcet winner at top. Okay. In general, this is NP hard. This problem is NP hard and does not belong to NP unless some complexity theoretic assumption fails. So it is complete for even higher complexity class. It should be clear that it is not obvious why this problem belongs to NP. Yeah, but for single peaked domain, this is polynomial time solvable. So as I said, whatever is hard, single peaked is very good. Not only that median welfare function, median voting rule, you get a welfare function, make it output a ranking. That ranking will be same as Kemeny ranking in single peak domain. So in this sense, I mean that there are very good properties, all good properties you can think of that median voting rule has. This is among very popular voting rule because it satisfies many desirable properties. There are many properties which you want to satisfy. For example, another view of this is of another motivation of this particular method is there is a ground truth. There is a ground reality true ranking of the candidates, and every voter makes a noisy observation. So if you look at this, then Kemeny ranking is the most likelihood estimate. If you know these terms, this is a MLE estimate of the ground ranking. Needs a proof, but not difficult to see also. So there exist voting rules for which determining winner is hard computationally. So it makes sense to study this from parametrics point of view, approximation point of view, and it has been studied. So for approximation, we know a Peters. This was a stock paper. So we have a PTAS which says polynomial time approximation scheme, and it has been exhaustively studied. It's among one of the few well studied voting rules. So these are the kind of problems in computational social choice. So there are some more voting rules for which they are also hard, and we study algorithmically. What are the algorithmic thing for this question, for this rule? Another interesting question which has already been resolved is what is the right complexity. It is NP hard, but it does not belong to NP. So it turns out there is something called theta 2p, some parallel NP, something for some higher class. They have shown that it is complete for this class. So that comes under this winner determination kind of framework. Okay. Yeah. The second one, let me see. This is the first. The second is multi-winner voting rule. In multi-winner voting rule, it's like committee selection rule. I want to pick k candidates. Okay, not one winner, not ranking. I have say like k positions, k job openings, and I want to select k candidates, right? Let me explain slightly. So here again, as I said, often in PhD student hiring or faculty hiring, question boils down to approval kind of setting. So is it good or bad? So for approval ballots, that means each voter V1 has a set subset, approves some subset of candidates. A2 V2 approves certain set of candidates, and Vn again there are many multi-winner voting rules. Let me tell you one which is quite appealing, is that there is an equivalent way to view subset as Boolean strings. So how? So this A1 you can view it as a Boolean string indexed by 1 to m length Boolean string. M is the number of alternatives, and here I have 1. If 1 is A1 is approved by voter 1 and 0 otherwise. So if in this position I will have 0 if A2 does not belong to A1, and so on. So 1-to-1 correspondence. So each vote you see like a Boolean string.
Sir, one doubt.
Yeah.
So say we have k job openings. So each voter has to give k approvals.
There are various models. So in this case, we are assuming they can approve any number of voters, any number of candidates.
One person will think only one is
Yes.
eligible, everyone else is not. So
Yes.
he will give.
Correct. Yeah. But that also makes sense. So and has been studied. So now, if the votes look like these Boolean strings, then there are again various options. One natural one is you count for each alternatives how many ones you accumulate, and that is the top k guy you pick, right? That is called approval rule. As you can see, that is polynomial time solvable. There is another one which is also appealing, is motivated by this basically. The problem with this approval, so let us define. So for every Boolean string of length m, you define some notion of distance, which makes sense here. So you see, you say distance of x and this set A1 to An. Now, if you have two Boolean strings, so you have to write distance x and say, let me write A. Think of AI as a Boolean string of length m, x is also a Boolean string of length m. Can you tell me a natural notion of distance between two strings? Having distance or same. So let me write having distance. Number of positions where they differ. Same as XOR. You XOR and see what are the number of ones. So now again it makes sense. So the analog of K-mini is the output is that x which has minimum distance. That is one. Another one, so this is called min sum. Unlike K-mini, computing min sum, computing an x which minimizes this sum is polynomial time soluble. On the other hand, but researchers never like easy problems because they are job security. You have to convince that life is hard, problems are hard, you need me. So what they do, they tweak it slightly and they define. Actually, yeah, this is the thing, and there is another more natural notion of distance of an element from a set. Is max of distance. So it's like maximum unhappy a voter can be from X. So maybe from fairness notion it may make more sense. So this notion is sometimes called utilitarian approach. We want to maximize the sum of happiness or minimize sum of unhappiness. So this is like utilitarian model. I think she was also talking about this thing, utilitarian versus egalitarian, and this is a egalitarian. Where we want to minimize the maximum unhappiness. You see, communism versus social capitalism. So this is hard. Computing this is hard, and again people have studied from parameterized approximation and this sort of thing. And there are various other voting rules also. Yeah, sorry. This is called min-max voting rule. Min-max. You minimize the max. Here is minimize the sum. Min sum. Yeah, good. Thank you. Okay. Last but not the least, let me introduce another view of voting rules, because this year's SODA or last year's SODA, I think this year's SODA, the best paper award was on this problem, this notion which is called metric distortion of voting rule. what you do, you have again rankings and a voting rule R. These most of the voting rules have been defined classically with what seems right, and also studied axiomatically. Axiomatically means what properties they satisfy, like condensate consistency, strategy proofness, unanimity, and so on. Here is another computer scientist point of view. So this is very I don't know, very computer science style, more objectively how good a voting rule is, right? If you have two voting rules, one voting rule satisfies say 5 out of 20 properties, other voting rule satisfies 10 out of 20. It's difficult, which all properties are not of same importance. So this sort of tries to quantify the goodness of a voting rule, the idea, yeah. So let me define what is distortion of a voting rule given a preference. So what you do, there is always a embedding. What is an embedding? Embedding is so let us call it E from these voters and alternatives. You embed them in some r to the power k. In some Euclidean space, you embed them such a way that these rankings make sense. What do you mean by rankings make sense? Embed them means that each voter and each alternative you assign to some points in this space. Now, what do you mean by make sense? These rankings make sense. Make sense means there are these are, suppose these are alternatives A1, A2, A3 and so on. Now look at the point for V1. Now look at the closest, look at Euclidean distance between V1 and all these alternatives and ask who is the closest candidate. That closest candidate should be the most preferred. Second closest should be the second most preferred and so on. So if this happens for all voters, then we say that this embedding explains these rankings, is consistent with this ranking, right? Maybe they are in some high dimensional decision space, complex decision things they are doing with various things. So there is embedding. Now of course voting rule does not have this embedding, they have these rankings and they have to decide based on the ranking. But suppose you have access to this embedding, then what is the best thing to do? In some sense the best thing is to pick that candidate whose sum of distance to all the voters is minimized. It is like closest to most of them, like in again utilitarian sense, and under this sense only it is studied. Okay. So arguably if I am given a embedding, the best candidate is that candidate whose sum of distances to all voters is minimized.
More preferred one is more closer.
Yes, more preferred one is more closer. So you compute the winner based on this embedding and call that distance d or d of WE is the winner based on this embedding, and distance of this to all the voters. These are points, you sum them, this is the distance, and this is the best thing. Compare this with distance of winner of R So, let me write this WR V1 to Vn. So, WR is the winner picked by this voting rule R. So, this ratio depends on embedding, of course depends on these preferences. So, computer scientists study worst case thing. So, you maximize this over E and P1 to Pn. So, over all preferences, preference profiles and over all embeddings, how bad the winner picked by this voting rule R can be compared to best guy, best winner, if I have the embedding.
For all embedding, with some bound on K.
No, it is basically there are some canonical things which you can show that these are the best.
And embedding,
So, this will be in general a function of m and n, and the smaller the this thing is, this is called the distortion of R. Distortion of the voting rule R, and the smaller the distortion the better.
is it even finite number of embedding?
No, not finite. So, so a priori it not clear. So, okay, let me make it soup then. Yeah, good. Supremum, yeah. So, we for classical voting rules, what are the distortions? Not surprisingly, the distortion of scoring rules are bad, high. There are some voting rules whose distortion is relatively less, and there was some gap between upper bound and lower bound. Means how what could be the smallest distortion of any voting rule you can design, and what is the largest. And so, this paper, this best paper of Soda this year's sort of broke those barriers, means in some sense, yeah. But this is the idea. So, this is sort of the main spirit and the definition of distortion. And there are, before that Soda also there are couple of papers, series of papers, all in good venues. So, this is again one current area of research, and after that Soda paper also there is still gap. So, if you are looking for contemporary work, this is very contemporary. Okay, I think let us stop here. Yeah.
Why don't we make a voting rule where the winner is that?
Computing this is difficult. Computing this is difficult. How can I how will I compute W over which will minimize over all embeddings and this sort of thing?
The computation would be very. So how do you compute the ratio without computing the?
It's like we do the math. We bound, we show that this is less than equal to this, greater than equal to this. I don't have to compute. For example, proving existence of Nash equilibrium was in 1950s, but computing a mixed strategy Nash equilibrium is hard. Yeah. There are various ways to prove, to show something exists. Suppose it does not exist, then this is. But in computing, you cannot say suppose you do not exist.